Good morning, friends. Once again, welcome on the lecture series, of course, Elements of Machine Design. We have started chapter number 6, that is selection of anti-friction bearings and gears. In first chapter, we have seen the introduction about the bearing, the function of the bearing, classification of bearing, how the bearings are classified, rolling contact bearings, ball bearings. In lecture number 2, we will continue with the classification of the bearing and some basic terminology regarding the bearings. So, continue with the bearings. Next classification is types of roller bearings. In last lecture, we have seen the types of ball bearings. In this lecture, we will understand what is meant by the types of roller bearings. So first type is the cylindrical roller bearing. As the name suggests, the portion of the inner race and outer race is cut through and the shape of the bearing is a cylindrical type. That's why it is known as the cylindrical contact bearings or cylindrical roller bearings. As usual, as seen in the first lecture, this is the outer race, this is the inner race. Two retainers are provided here. This is the rotating element. This is the shaft, this is the rotating element. So these are the roller bearings. Instead of ball, only rollers are inserted in between the inner and outer race. That's why these are known as the roller bearings. So these bearings have short rollers guided in cage, or what we can say retainers. These bearings are relatively rigid against radial motion and have the lowest coefficient of friction. Any form of heavy duty rolling contact bearings. Such type of bearings are usually in high speed service. The application of this bearing is high speed service. As we know that in case of the roller contact bearing, the advantage of the roller contact bearings over the sliding contact bearing is that it has the low coefficient of friction at very high speeds. So this is the one of the advantage of this having the roller contact bearings. So application of this bearing is the high speed services. The most important part in the bearings is the selection of bearing for a particular applications. So keep in mind, just concentrate on the applications of bearings. The most important part is the in which applications different types of bearings are used. So cylindrical roller bearings are used in the high speed services. Now second type of the roller bearing is the spherical roller bearings. These bearings are self-aligning bearings. The self-aligning feature is achieved by grinding one of the races in the form of sphere. Self-aligning means it can align itself at very high speeds. Depending upon the nature of the load, though there is a variation in the load, these bearings can align itself in a cage or retainers. So to have this facility, these races are cut in the form of a spherical form. These bearings are normally angular misalignment in the order of 1.5 degree. Second advantage is that it can tolerate angular misalignment of order of 1.5 degree. These can carry thrust loads in either direction. We have understood what is meant by the axial load, what is meant by the radial load, what is meant by the thrust load. So where there is a thrust load in either direction, in that case we can go for the spherical roller bearings. So this is the application of the spherical roller bearing. When there is a thrust load in either direction, we can go for the spherical roller bearing. When we are using high speed services, we can go for the cylindrical roller bearing. Once again, I remind you, please keep concentrate on the applications of the different types of the bearings. Next type of a roller bearing is the needle roller bearing. These bearings are relatively slender and completely fill the space so that neither a cage or retainer is needed. So in between the inner and outer race, these bearings can easily incorporate it, or these bearings can fill the space in between the inner and outer race. So there is no need of cage or retainers to keep them in a particular position. That's why these are known as the needle roller bearings. Means these are the slender in type and they can accommodate the complete space in between the inner and outer races. These bearings are used when heavy loads are to be carried with an oscillatory motion. The best example is the piston bearing in heavy duty diesel engines. If you take the example of a piston pin bearing, you will find that total space is occupied by the bearings when there are heavy loads with an oscillatory motion, where the reversal of motion tends to keep the rollers in correct alignment. That's why there is no need of a retainer or cage, because reversal of motion tends to keep the rollers in correct alignment. So application of needle roller bearings is when there are heavy loads are to be carried out with an oscillatory motion. This is the application of needle roller bearing. Next type of bearing is the tapered roller bearing. This is the tapered shape. That's why these are known as the tapered roller bearing. The rollers and raceways of these bearings are truncated cones. Look at this shape of the cone. These are the truncated cones whose elements intersect at a common point. Such type of bearings can carry both radial and thrust load. When there is a application of radial as well as thrust load, then we can go for the tapered roller bearings. These are the applications of these bearings. When there is a loads are in both direction, thrust as well as in axial direction, then we can go for the tapered roller bearings. So this is the application of tapered roller bearings. The shape of the bearing is in the form of truncated cones. So these are the four types of the roller bearings. Cylindrical roller bearing, these are used in high speed services. Spherical roller bearing, these are used when thrust loads in either direction is acting on a shaft element. Needle roller bearings, these are used when heavy loads are to be carried with an oscillatory motion, and tapered roller bearings are used when there is a radial as well as thrust loads. Now we will go through some terminology of roller bearings. In last lecture I have told you that we have to focus on the roller bearings. Our syllabus is restricted up to roller bearings. So we need to understand the basic terminology of roller bearings. Some terms are there, some terms are associated with the bearings. We need to try to understand what are these terms. So start with the first term associated with the roller bearing, that is the basic static load rating. What is meant by the basic static load rating? The basic static load means the load which is not when there is a constant force or constant load acting on the bearing. That is the static load. It is not the dynamic load. That is the basic static load rating bearing. Basic static load rating of a bearing is defined as the static radial load. The load which is acting on a radial direction in case of ball or roller bearings, because ball or roller bearings these are the roller bearings. A static radial load which is acting on a bearing, or axial load in case of a thrust ball or roller bearing. If there is a radial ball or roller bearing, then there will be a radial load, and if there is a thrust ball or roller bearing, then there will be an axial load, which correspond to an actual permanent deformation of the roller or ball and race at the most heavily stressed contact equal to 0.0001 times the ball diameter. Once again, tries to understand. The basic static load rating is defined as the static radial load or axial load which corresponds or which causes the total permanent deformation, permanent not temporary, axial load or radial load, that is the static axial or static radial load, which causes permanent deformation of the roller and race or ball and race at the most heavily stressed point, equal to 0.0001 times the ball diameter. If due to the application of radial load or axial load, if there is a permanent deformation of a roller or ball at a most heavily stressed point, how much permanent deformation should be there? If that permanent deformation is 0.0001 of its roller or ball diameter, that load is known as the basic static load. अंडरस्टैंड? समझ में आया क्या? अगर उस पर एक्टिंग होने वाला लोड, जो लोड उस बेरिंग पे एक्टिंग होता है, अगर वो लोड जिसको हम स्टैटिक लोड बोलते हैं, एक्सियल हो या रेडियल लोड हो, अगर वो लोड उस बेरिंग को और उस रोलर और बॉल बेरिंग को, अगर उसमें टोटल परमानेंट डिफॉर्मेशन प्रोड्यूस करता है, इफ इट कैन प्रोड्यूस a total permanent deformation due to the application of axial or static axial or radial load, but it should be static load. If due to this there is a permanent deformation, how much permanent deformation? 0.001 times the ball diameter. That load is known as the basic static load. समझ में आया क्या? अगर basic static load अगर बेरिंग पे एक्ट होता है और वो बेरिंग पे एक्ट होने के वजह से अगर बेरिंग में परमानेंट डिफॉर्मेशन पैदा होता है, कितना होना चाहिए परमानेंट डिफॉर्मेशन? 0.001 टाइम्स इट्स रोलर और बॉल डायमीटर. वो जो लोड होता है उस लोड को कहते हैं बेसिक स्टैटिक लोड रेटिंग. दिस इज द टर्म एज द बेसिक स्टैटिक लोड रेटिंग. सेकेंड इज द स्टैटिक इक्विवेलेंट लोड. In above definition, we have seen what is meant by the basic static load. Now understand what is meant by the static equivalent load. The static equivalent load is defined as the static radial load or axial load, which if applied would cause the same total permanent deformation at the most heavily stressed ball or roller and race contact as that which occurs under the actual conditions of loading. If static equivalent load means what? Due to the application of that static load, if the total permanent deformation in that bearing is same as that of the actual permanent deformation when it is applied to specific conditions, that load is known as the static equivalent load. Means what? अगर उस बेरिंग में स्टैटिक लोड अप्लाई करने की वजह से टोटल परमानेंट डिफॉर्मेशन होता है, कितना होता है? अगर सेम बेरिंग हम एप्लीकेशन में यूज करते हैं और उसमें जितना एक्चुअल परमानेंट डिफॉर्मेशन होता है, अगर उतना ही एक्चुअल परमानेंट डिफॉर्मेशन एक स्टैटिक लोड अप्लाई करने से होता है, तो उसको बोलते हैं स्टैटिक इक्विवेलेंट लोड. द लोड विच इज इक्विवेलेंट टू द लोड विच इज एक्टिंग इन प्रैक्टिकल कंडीशंस एंड विच प्रोड्यूसिंग द सेम टोटल परमानेंट डिफॉर्मेशन एज दैट इन द एक्चुअल कंडीशंस ऑफ लोडिंग. दैट इज नोन एज द स्टैटिक इक्विवेलेंट लोड. Now next definition is the rating life of bearing. This is most important definition. Rating life of bearing means we are rating the life of bearing. It is the actually life of bearing. How we can define a life of bearing? कितने समय तक हम उस बेरिंग को यूज कर सकते हैं, उसको बोलते हैं लाइफ ऑफ बेरिंग. For how much time period we can use that bearing. that is known as the life of bearing, and how it can be defined as the rating life of a group of apparently identical ball or roller bearing. Apparently identical ball or roller bearing is defined as the number of revolutions that 90% of group of bearings will complete or exceed before the first evidence of fatigue develop or fatigue failure. Means what? अगर हम bearing ले ले, suppose take the example, if I will take 10 bearings of same identical properties, spherical roller bearings or needle roller bearings. If I will take a group of 10 roller bearings, and if out of that 10, 90% of group of bearings will complete, means out of that 10, if 9 bearings will complete or exceed before the first evidence of fatigue failure. अगर out of 10, अगर 9 bearings कितने समय तक टिक पाते हैं, for how much time period we can use that 90% of bearings before first evidence of fatigue failure or fatigue development. That is known as the life of bearing. Means it is calculated on the basis of for how much period of time 90% of the bearings will sustain before evidence of first fatigue failure. That is known as the rating life of a bearing. Understood? Next is the basic dynamic load rating. In previous slide we have seen what is meant by the basic static load rating. In the same manner we will understood what is meant by the basic dynamic load rating. Dynamic means there is a change in load. The basic dynamic load rating is defined as the constant stationary radial load or constant axial load, same as previous, radial load or axial load, which a group of apparently identical bearings, means group of identical bearings with stationary outer ring can sustain or endure for a rating life of 1 million of revolution with only 10% of failure. If the identical group of bearings can sustain a rating life of 1 million of revolutions with only 10% of failure, that load is known as the basic dynamic load rating. If constant stationary radial load or constant axial load is acting on that bearing, depending upon whether it is a thrust bearing or radial bearing, and if under the application of this one of the load, if a group of that identical bearings with stationary outer ring can sustain a rating life of 1 million of revolutions with only 10% of failure, then that load, that radial load or that axial load which is acting on bearing is known as the dynamic load rating. With reference to that load, we are calculating this rating. That's why it is known as the dynamic load rating. Understand? अगर सेम बेरिंग्स पे स्टेशनरी रेडियल लोड और स्टेशनरी एक्सियल लोड एक्ट होता है और उस लोड की वजह से, और व्हेन दैट लोड इज एक्टिंग ऑन द बेरिंग, इफ that bearing can complete 1 million revolutions with 10% failure, then it is known as the basic dynamic load rating. 10% failure means 90% of the bearings should have complete this criteria. That is the basic dynamic load rating. Next is the dynamic equivalent load. In previous slide we have seen what is meant by the static equivalent load. Same, we have to see what is meant by the dynamic equivalent load. The dynamic equivalent load is defined as the constant stationary load or axial load if applied on a bearing with rotating inner ring and stationary outer ring, will give the same life as that which the bearing will attain under the actual conditions of load and rotation. It is the comparison between the actual load and applied load. If we applied a constant axial load or constant radial load, and if that bearings will give the same life as that of the actual working conditions, then that load is known as the dynamic equivalent load. That is the concept of dynamic equivalent load. Next is the critical pressure. The pressure at which the oil film breaks down so that metal to metal contact begin is known as the critical pressure or the minimum operating pressure of the bearing. We know that there is an oil film in between the stationary part and bearing to reduce the friction between the rotating elements, and the pressure at which that oil film breaks so that metal to metal contact begin is known as the critical pressure. In simple language, the pressure at which the oil film breaks and there is a metal to metal contact begins, that is known as the critical pressure. Its value is given by this formula: critical pressure or minimum operating pressure. Next is the Sommerfeld number. The Sommerfeld number is also a dimensionless parameter. What is the application of this? Used extensively in the design of journal bearing. Now this Sommerfeld number, for the design purpose, for the design of bearing, we are using this value of Sommerfeld number. Its formula is like this: Sommerfeld number. The same formula is used in the critical pressure, Zn by P. If you just adjust this formula, you will get 4.75 into 10 raised to 6. If you take on this side, P will come on this side, then Zn by P into D by C bracket square. That is the Sommerfeld number. Now this number is used in the design procedure of the journal bearings. So this is regarding the terminology of the bearing. What we have seen: basic static load rating, static equivalent load, rating life of a bearing or life of a bearing, how we can define for how much time period we can use that bearing, that is the life of a bearing, means number of revolutions that bearing can complete, or 90% of the group of bearing can complete before the first evidence of fatigue failure, that is the life of bearing. Basic dynamic load rating, dynamic equivalent load, critical pressure, the pressure at which the oil film breaks between the bearing and outer race or bearing and stationary element, and there begins a metal to metal contact. And Sommerfeld number, it is a dimensionless number which is used for the design of bearings or journal bearings. So this is regarding the some basic terminology of the bearing. I hope you would understood the concept of the different definitions associated with the bearings. Thank you.